In this video, let me discuss the alternating pattern for the hydroxy groups on glucose specifically, and then I'll sort of broaden the topic to more general carbohydrates. So let's look at the glucose molecule as in the Haworth structure. Right, all of these Haworth structures start out with some, 6 or 5 membered ring. Oxygen is going to be one of the atoms in the ring. Just to the left of that oxygen, you'll see the CH2OH, and then there's like this pattern that you see going around the ring structure for the hydroxides to define whether it is, and for our class, glucose or galactose. For glucose, there is an alternating pattern. Alternating meaning as you go around the ring, then you can say this one's on top, this one's on bottom, this one's on top, that one's on bottom. I think of the atoms in the ring structure as like a plane, and then above the plane you have this guy and that guy, and then below the plane you have those two. Now, to finish off the structure, let me just add the final touches here. Let's just put the hydroxy group pointing up. If it's pointing up here, then that is the beta D-glucose. So in a separate video, I deal with the alpha and beta anomers and how they switch back and forth. So really, the answer to this question is yes. Okay, it's only glucose, D-glucose, that has this particular pattern where the hydroxy groups are alternating as you go around the ring structure. And notice I'm including this guy as well. If you change any of these orientations, you have some other sugar. Like for example, if I change this position, keeping everything else the same, I no longer have glucose. I still have a beta sugar, right? That beta is in reference to that guy. But now instead of D-glucose, I actually have D-galactose. And that's really the only other aldohexose sugar that we see in our course. But there's a bunch of these. If you type in, isomers of glucose on Google, you'll get plenty of structures to look at. And what you would see is that every time the pattern of the hydroxy groups change, you have a different sugar here. So again, yes, this alternating pattern is what defines glucose. This alternating pattern is what, basically allows D-glucose to be metabolized in the body like it does for the energy production through the process known as glycolysis, which helps feed into like the citric acid cycle and then the production of ATP in the mitochondria ultimately. D-galactose, even though there's only one change here, cannot feed through that particular pattern. It would have to be, it's a different pathway. And I think I'll leave it at that. Okay, thanks.